Hello, and welcome back to biology. Today we want to talk about living in groups. Why do organisms live in groups? I mean, why isn't it just everybody fends for themselves? And in certain instances, that's true. But there are a couple of really good reasons for living in groups. And the first one is habitat saturation. You live in an area that has limited resources and it doesn't have a lot of suitable habitat. If that's the case, you have two choices. You can leave the area and try and establish territories, maybe in less desirable areas, or you can join a group. Now, you'll probably be a subordinate, but when you join the group, there's the possibility of mating opportunities. Perhaps you could inherit the territory, or you could survive until a suitable territory can be obtained by you from someone else, right? Now, another reason for living in groups, kin selection. Relatives. We share genes with our relatives, and when you help a sibling or a parent raise their young, it's almost as good as reproducing yourself. You can also, again, back to kin selection, live with your parents until you're older, right? Juveniles stay with the group because, and this is like kin selection plus, right? Because you help raise your genes, but also you can learn from your parents' life skills. Then when you're older, you can survive on your own, leave the nest, and establish your own territory. And this is really common in birds. All right, and the benefits of social living are huge, right? You get improved detection of predators. You've got many eyes, right? You can repulse predators. Not only can you see them, but you can actually attack them in mass, right? En masse, yeah. So here are some ring-tailed lemurs. These are all females, by the way. Well, this one may be a male, but the ones in front are definitely females. They will actually have little sort of armies, if you will, that will go and attack. They'll have raiding parties, that sort of thing, but they'll actually battle. And here you have two predator groups, or sorry, wow, that was crazy talk, prey groups. These are bait fish, and these are obviously zebras. It is very difficult to identify a single individual, and so it makes it very difficult for a predator to lock on to one, and so there's a lot of confusion. So the repulsion of confusion could be attacking in a large group or confusing them. Then also, there's not a whole lot more intimidating than a giant muskox staring you right in the face. And you can't really see this in this picture, but there is actually a baby that is nestled in between, well, in the center of this big group of adults. Okay. Now, there are some costs of social living too. And the first one is increased competition. And it's what we talk about all the time. I mean, the more individuals you have, the more competition you're going to have. And it's going to be for food, for mates, for any resources. There's also an increased vulnerability in high population densities to disease and parasitism. Because obviously, if you're around more individuals, there's the more you are more likely to get whatever they have, and parasites and pathogens do really well in close quarters because they can just jump from one individual to the next. And then, of course, if you trust your group members, there is the risk that they will exploit that trust, and it is called cheating, and we will come back to that in just a minute. Now, social behaviors require trade-offs. There's a cost-benefit analysis, basically, that happens in every behavior, okay? And social interactions are behaviors that will have fitness consequences for two or more individuals. These are going to be of the same species, by the way. This is going to exclude parenting and mating, because parenting and mating have costs that are never recouped except in the passage of genes, right? And so if your offspring survive, the cost to the individual parent or mate is greater than their immediate benefit, but the long-term benefit is the genes, okay? Now, in every social interaction, there's going to be an actor and there's going to be a recipient or many recipients, and an action is beneficial if it increases fitness, and it's costly or detrimental if it decreases fitness. And at this point, I just want to remind you that there's a difference between survival and fitness. Survival means that you live, right? And survival's great because you do want to live long enough to reproduce. But you could have 1 million babies, and if none of them survive, your fitness is zero. No matter how long you live, no matter how great you are, no matter how awesome your life is or whatever, you have a fitness of zero if you do not have surviving offspring. Fitness is all about passing on genes. Survival is about living. Okay, so altruism, right? the social interactions, oh, well, that's fun. Okay. I have my slides in the wrong order. We'll just come back to that. So there are four big social interactions. There's cooperative interactions where everybody benefits. That's mutualism. There are selfish actions where the actor benefits and the recipient's harmed. And that's parasitism is a really good example of that. So the parasite benefits, the host does not. In some cases, the recipient benefits and the actor's harmed. That's altruistic behavior. And then if the actor is harmed and the recipient is harmed, that is what we call spiteful. And altruistic is really interesting because it's not really reasonable for you to sacrifice yourself if you're trying to survive to pass on your genes. But there may be some benefit to that, and we're going to talk about that in just a second. I will tell you right now, spiteful is never going to work, right? It's never going to work out to the benefit of anyone because everybody is harmed, right? That's that whole idea of, cut your nose off to spite your face, right? It's not a very good idea. Same idea. Okay, so here's the next slide. Altruism. Why would you make sacrifices? Ignore this part. Okay, so let's say that you have a bunch of little squirrels. There is a cat. Now there's some options. The squirrel could act selfishly and not call anything. Oh, I see the cat, right? Me, I see the cat. So by not calling, this squirrel is helped because it doesn't direct attention to itself. But in many cases, it actually will. Okay, it'll give a warning call, and that is an altruistic act because if you make little squeaky noises, kitty is bound to hear you, right? And that is probably not in your favor. But all of these guys now know that there's kitty over here. So, why? Why would you do this? Okay. Well, most altruism, there's very rare, true altruism is almost non-existent, where you actually just sacrifice for the good of somebody else. Most of the time what you have is something called reciprocal altruism, and you can call this tit for tat. I do this for you, you do this for me. In other words, you scratch my back, right? I'll scratch your back. So the idea is that there is this sense of fairness. There is the idea that I will be honest, and I will help you, and I expect you to be honest and help me in the long run. Now, this depends on the recognition of cheaters. You cannot allow cheaters if you're going to have reciprocal altruism as your strategy for survival. And by the way, everything in here is all adaptive behavior, right? Reciprocal altruism, kin selection, all of those things, they increase fitness in some way, and so over time have become part of the way animals behave, right? And again, we're mostly talking about birds and mammals, okay? But back to this. It's going to depend on you not sacrificing for an individual that is not willing to sacrifice for you, okay? So, cheaters cannot be allowed. Now, peacemaking is also an adaptive strategy, right? And this is a strategy for minimizing or containing violence. And territoriality is a really good example of that. Competition can lead towards violence. If you are in a social group, you probably don't want that. So within social groups, there'll be dominance hierarchies, and there will be little bitty kind of tiny territories oftentimes. That is a way to establish boundaries, and so it's not just a giant free-for-all. So, right, fairness, I work for you, you work for me, excluding cheaters, those who do not participate in the system, and being able to make peace are all really important for group dynamics. Okay, so each of the following conditions is required for reciprocal altruism to be favored, except the value of receiving help when needed must be less than the cost of giving future help. You must have multiple interactions with the same individuals. You must have sufficient long-term memory to remember past encounters, and you must be able to recognize cheaters and withhold benefits from them. Or all of these are required. Well, the value of your receiving help does need to be less than the cost of help in the future, and that is that cost-benefit analysis we're talking about. Now, you also want to be part of a group. If you're only going to have, in nature, if you're only going to have one interaction, now this does not apply to people, so don't be yucky. But in nature, if you're going to have only one interaction with another individual, then you probably want to do what's best for yourself. But if you're in a group, then altruism is going to probably be in your best interest, because you're going to have time to be paid back. You actually have to remember that you've done this, right? So the actor has to know, right, project out forward, right? But by the same token, the recipient's got to remember those past encounters. And again, no cheaters. Those that do not play well and pull their weight are not allowed. Yeah, that is how that works. So all of these things are actually required. Okay, so let's get back to this cost-benefit analysis, because really most things are about a cost-benefit analysis. So when you start looking at reciprocal altruism, it goes like this. The cost has to be less than the benefit times the likelihood that the actor is going to receive a benefit in the future as a result of paying the cost now. So let's get back to alarm calls. What we see is that in several bird and mammal groups, individuals will call to warn of approaching predators or aggressors or whatever. So this is interesting, because if you just make casual observations of this, then you'll actually see that the alarm caller is going to be attacked more often. So if you are putting yourself at risk, is this really altruism, right? So let's think about this. And I'm going to throw this little scenario out to you right here. In wild turkeys, two males often work together to compete with other male turkeys for access to fertile females. If the males are brothers, and usually one does most of the mating, this would be most likely an example of... So basically what this question is saying is that two males work together to get females, but only one of those males actually mates with the females, yet the non-mater is more than happy to work with it. So why? Well, there doesn't seem to be any sort of reciprocal altruism. One could say, well, maybe next season they're going to switch, right? But they typically don't, okay? It's not true altruism, because, again, that doesn't really exist. This is an example of kin selection, and kin selection is the answer to our warning call situation, and I'll show you why in just a second. But kin selection, in this case, you're choosing family. Ultimately, right, this is pervasive through all organisms that live as groups. And we even have like folk sayings that work with that. It's that do unto others as you would have them do to you. You scratch my back and I'll scratch yours, which is also the reciprocal altruism thing. When in Rome, do as the Romans do, conform to whatever the group norms are, and blood is thicker than water. Yeah. So in the first two, right, we're cooperating because there's the expectation and it is adaptive behavior, right? And so you can sort of fit in with that. And then the last one is all about kin selection. We cooperate with people because they share our genes. And this is going to be the most common root of group interactions, is that you are trying to increase your fitness. And the idea, Hamilton, actually, who came up with the theory of kin selection, came up with the idea that there's an inclusive fitness. So fitness is not just direct, that personal reproductive success, it also includes indirect fitness, right? This is the reproductive success of those related to you. Now, obviously, direct fitness is more, right? That's worth more, but indirect fitness is also good. So, in the theory of kin selection, genes associated with caring for relatives may in fact be favored by selection because they're helping genes get passed on, and everybody's sharing those genes because they're all working together, right? And then altruists will pass on the genes indirectly because relatives have copies of those genes and they survive and reproduce, okay? And this is actually called Hamilton's rule. And when we go back to that idea of cost-benefit analysis, Hamilton's rule is very similar to reciprocal altruism, right? Except it changes a little bit in that you have the benefit, right, to the recipient. You have the cost to the actor. Those are the same. But the other factor is going to be the degree of relatedness. And essentially it's like this. The cost to the actor must be less than the benefit times the degree of relatedness. Okay, so it's just like the other one, except instead of probability of action, you get degree of relatedness. Okay, and it works a little bit like this. You can calculate the degree of relatedness by looking at the pathways of relatedness. So you can connect the actor to the recipient. In this case, you have full siblings, right? So it's always going to be the pathway of descent is what that pathway of relatedness is called. Each arrow is a step or a gene transmission, a generation of genes transmission. So the mother gives genes to her offspring, right, is basically what we're saying here, right? Okay, now, the probability of gene transmission at each step is 1 out of 2. Because remember, you've got pairs of chromosomes. There's a 50% chance that you're going to get one over the other one when gametes are formed. And we already know this because we've talked about genetics and things like that. And we've talked about meiosis and all that. So, you sum all of the possible pathways and you multiply transmission events. Now, this sounds scary, but I'm going to explain it to you right now. So it works like this. We're going to start with half siblings. So when you have a half sibling, you are half, right, 50% related to your shared parent. Now, are you exactly that? Maybe, yes, you are, right? And that recipient is your sibling, right, your half sibling. You share a parent. So they're also 0.5, right, 50% related to their parent. You will multiply these two gene transmissions, meaning that you are 0.25, right, 25% related to your half sibling. Now, in a full sibling, does this make sense? Okay, so half related to your parent because you got half their genes. Your sibling, in this case the half sibling, is half related to the parent because they got half their genes. Multiply the arrows together and it's 1/4. Now, when you have full siblings, you have two parents that you share, a mother and a father. So we've got that same pathway that we saw before. Let's do this one because it's in the same place. So the actor is half related to the father, and the father is half related to the sibling. Okay, the mother is half related to the actor and to the sibling. So you've got your 1/2 times 1/2 is 1/4. Yes? Then you do it again. 1/2 times 1/2 is 1/4. 1/4 plus 1/4 is 2/4, which is 1/2. Okay? If you have any questions about this, please ask me in class. But that's how it works. You just look at the gene transmissions and add the number of pathways together. So let's say you want to talk about cousins. Well, first of all, let's talk about your aunt or uncle. So let's say you, right, are the actor and the recipient is your aunt or uncle. Well, half related to the parent, but remember siblings are 0.5 as well. So you've got 1/2 times 1/2. So you are 0.25, right, 1/4 related to your aunt or uncle. Now, what about your cousins? Well, they're half related because they're the offspring. So now it's 1/2 times 1/2 times 1/2, or 1/8. So you are 1/8 related to your cousin, right? And you can do this with any relationship. You just need to map it, okay? Now, back to warning calls. So when we account for kin selection, if the cost of giving the call is, say, 0.3, right? And I'm making these numbers up. And the benefit to each of the others in the group is 0.1, is this a good idea? Well, let's say all of the others are sisters of the caller, okay? So now there are going to be 8 sisters, yeah? So when we look at the calculations, the cost is 0.3, and then the benefit is 0.1, but there are 8 of them, so it's 0.1 times 8. The degree of relatedness to each of them is 0.5 because they're all sisters. So the relatedness times benefit is 0.5 times 0.8, which is 0.4. And in fact, 0.4 is larger than 0.3, so this is a good action for this little squeaker right here. Okay? So when we talk about altruism via kin selection, if you're talking about full siblings, you're more likely to take a risk because you're more related to them. So the benefit has to be at least 2 times the cost. Okay? But for half siblings or aunts or uncles, then you're not going to be willing to take as many risks because the benefit has to be 4 times greater than the cost. And for cousins, it's going to have to be 8 times greater than the cost. But there's still a risk that you're willing to assume, and you see it in all kinds of things, right? The ground squirrels we were talking about, warn sisters, daughters, aunts, and other siblings. Now, the reason they're only females is because they tend to be in groups of females, and so that's why we're talking about females. Lionesses, who also are hanging out in groups of females, will nurse cubs from sisters and cousins, and it's because the benefit is outweighing the cost. All right, now in some instances, like bees and wasps and things like this, you have huge groups of sterile individuals. So you have these sterile workers, right? And they will support a queen. Yeah, and termites do this. Actually, naked mole rats do it as well. But mostly, it's going to be insects, okay? So here's your question. The permanently sterile workers, why is this a thing? They're found only in insect orders. They reach a point in their development when they must decide whether it's better to stay or leave their family group. They have zero fitness. They can increase their fitness by staying at the nest and helping, or they're the haploid result of unfertilized eggs. Well, 5 is not true, but it stems from this idea of insects sometimes have a little bit of a different situation, and they can have relatedness of 0.75, but we're not going to actually talk about that, so 5 is not the answer. 1, they're not found only in insect orders, because I just mentioned naked mole rats. They don't really decide whether to stay or leave their family group. They just do. They're in it. Okay? They do actually have zero fitness if they are not in the group. But if they are in the group, they increase that fitness by helping to raise the offspring. And so you'll see this in eusociality is what that's called. That hive kind of thing is eusociality. So anyway, so they're going to increase their fitness there. All right, so the answer is 4. Okay, so how do you know, right? So we've talked about all of this group thing, but how do you know who's supposed to be in your group? And I like to call that knowing your friends. Most group bonds are developed and cemented through tactile communication. So what's going on in this picture? You have this pup, right, with a little nose to the ear. The pup's going to bite her ear to practice kill bite, right? So it's a little play, predatory play for hunting as an adult. The pup is playing with the mother's ear as if it were an object because it's developing motor skills. The pup is whispering what it wants for its birthday in the mother's ear. This is not the answer. And the pup is grooming the mother to strengthen the bond between them. Well, pups do play, and they do practice hunting skills. That is not this. They also do play with objects to help develop motor skills. That is also not this. In this case, the nuzzling that the pup is doing of the mother's head is grooming, right, and bonding. They are bonding through tactile communication, touch. So the answer is number 4. And it works a little bit like this. Communication, right, touch is a very limited form of communication. It's found most frequently in mammals, but social birds will also groom each other. But basically, it's connection, right, that physical proximity, the physical touching. Bonding, grooming, and it's beneficial because 1, grooming actually removes parasites, it makes you healthier, and there is that idea of connectedness. And there was a sort of inadvertent study that was done in a Romanian orphanage where a while ago where they had all of these babies who were orphans, and they were all doing what's called failure to thrive, except 1. And failure to thrive is where they're losing weight, they're sickly, they're not thriving. I mean, they're not on their way to surviving and being healthy, except 1. One of the babies was healthy and happy and having a great time, gaining weight, and so they put cameras in the room to see what was going on, and it turns out that one of the employees was coming in at night and holding the baby, right? And the baby, because of that touch, was thriving, right? And so we know that there is something very primitive that causes us to be healthier and happier and more connected when we have an actual physical connection. And it's not just intra-specific, right? We love our pets, we hug our dogs and our cats, and other species do it too, right? And there's the really famous case of the polar bear that came to play with the huskies, and hugging was a big part of that. And then, how do we know that someone is touching us? Well, that goes to the idea of senses, and part of our conversation about communication is going to be about senses, right? How do you know what's going on around you? And touch relies on what are called mechanoreceptors, and they're in the skin. And you have all kinds of receptors in your skin, actually. But the mechanoreceptors are going to deal with pressure, okay? And so you're going to have your hairs, right? Movement of your hairs will let you know that there's something around you. And then also pushing on the skin, compressing it, we'll let you know too. And this little hand in your PowerPoint links to a website that explains all about how mechanoreceptors work. Okay, so that is it. And this begins our conversation about communication. How do animals communicate with each other? If you have any questions about any of this, please let me know, and I will see you in class next time. Thanks for listening.